Hello everyone. Today's topic, properties of exponents. Our essential questions. What are the different properties of exponents? And what does it mean when there is a negative exponent or an exponent of 0? Let's get to it. First off, an exponent or power is the amount of times a number is multiplied by itself. So normally we'd have a base, which is a bottom regular number, and to the top right a smaller number, which we call the exponent or the power. This will tell us to multiply 5 by itself 4 times. Let's look at a couple examples. Here we have 7 squared, or 7 to the second power. We can expand this to 7 times 7, which would give us 49. Our second example, we have 5 to the third power, or 5 cubed. That's expanded to 5 times 5 times 5, which would give us 125. You try this one, 4 to the fourth power. Okay, if we expand that, we'll get 4 times 4 times 4 times 4. That's 4 multiplied by itself 4 times, which would give us an answer of 256. Let's take a look at multiplication. And for all of these, we're going to take the goal of writing with a single positive exponent. When multiplying exponents with the same base, you can add the exponents. Here we have our first example, 7 squared times 7 to the first power. That's going to be expanded to 7 times 7 for the 7 squared, times another 7 for 7 to the first, and we could write that as 7 to the third power because there's 3 total. A shortcut would have just been doing 2 plus 1 to get an exponent of 3. For the second example, it looks like we have 5 to the third times 5 squared. That's 5 times 5 times 5 times 5 times 5, giving us a total of 3 plus 2, which is going to be 5 to the fifth power. You try this last one, 4 squared times 4 squared. Make sure you expand it and give your answer. Let's see how you did. If you expanded it, we should have 4 times 4. Again, 4 times 4, which would give us a total of 2 plus 2, or 4 fours. So 4 to the power of 4. Moving on to division. When dividing exponents with the same base, you can subtract the exponents. The base and exponent will be left in the bigger of the numerator or denominator. The others cancel out and give us that 1 that we discovered while working in our workbook. Here's our first example, 7 to the third divided by 7 to the first. That would be 7 times 7 times 7 in the numerator, 1 7 in the denominator. And if we were working with these, we can see that one of these 7s would cancel out to give us a 1. And then we have 2 7s left over in the numerator. That would be 7 squared. Let's look at example 2. Here we have 5 squared, which we expand to 5 times 5, divided by 5 to the fifth, which expands to 5 times 5 times 5 times 5 times 5. And in this case, it looks like we have one of the 5s that will cancel, 2 of the 5s that will divide out into giving us a 1, which leaves us with just these 3 5s left, but in the denominator, that's going to give us an answer of 1 over 5 to the third. Notice that we could also do 5 minus 2 or 2 minus 5, which gives a negative 3 or a 3. There's going to be 3 left in the denominator. Okay, you try this last one. 4 to the 6th divided by 4 to the third. Expand and give your final answer. Let's see how you did. If you expanded that, you should have had 6 4s in the numerator, 3 4s in the denominator. 3 of the 4s are going to cancel out. 1, 2, 3. Those all divide out to give us 1s, leaving us with 4 to the third in the numerator. We don't need the fraction because there's a bigger exponent in the numerator than the denominator. Let's take a look at powers of powers. When there's a power of a power, you can multiply the exponents. Let's look at our first example. 7 squared to the third power. That's 3 groups of 2 sevens. So 7 squared times 7 squared times 7 squared. That's going to give us 2 sevens plus 2 more sevens plus 2 more sevens, giving us a total of 7 to the 6th power, which we also could have got by doing 2 times 3, because there's 3 groups of 2. 7 to the 6th. Second example, 5 to the 4th power to the 2nd power. That's 2 groups of 4, so 5 to the 4th times 5 to the 4th, giving us a total of 8 of those 5s. 5 to the 8th power. Shortcut would have been doing 4 times 2 to get that 8. You try this last one. 4 to the 3rd to the 3rd again. All right, if you expanded that like we did in the other ones, you would have got 3 groups of 4 to the 3rd, 4 to the 3rd times 4 to the 3rd times 4 to the 3rd, and a total of 4 to the 9th power. Adding these up or shortcutting, 3 times 3. Flip your page over to negative exponents. When an exponent is negative, you can flip it to the other side of the fraction and make it positive. This is because a negative exponent is like dividing by the number instead of multiplying. Let's look at our first example, 7 to the negative 2. What we can do, instead of multiplying 7, we're going to be dividing. So we're going to flip that into a fraction, and we'll have 1 over 7 squared. So we took that negative 2, flipped it to the denominator, and made it positive. Here's our second example, 1 over 5 to the negative 2. This time we have a negative 2 in the denominator as our exponent. Again, we would be dividing, so we can flip that, giving us 5 squared without the fraction, just flipping that over to the numerator. You try this last one, 4 to the negative 8. All right, if you flip that to the denominator as a fraction, 1 over 4 to the 8, you would be absolutely correct. So whenever you see a negative exponent, you know you're going to be dividing, meaning you can flip it over to the other side of the fraction. All right, we save the hardest for last, exponents of 0. Now this is actually an interesting concept, but it's pretty simple if you can kind of remember it and make sense of what's going on. When there is an exponent of 0, the value is always 1. This is because the number being multiplied and divided is the same. Here we have 7 to the 0, that's going to be 1. Here we have 5 to the 0, can you guess? 1. All right, you try this last one, 4 to the power of 0. That is also 1. Did you get it? Nice job. Just as a side note, if we have the same number on the top and the bottom, those exponents would subtract out, leaving us with just a 1 anyway. We never want to cancel things out with the 0, so we always make this exponents of 0 a 1. Okay, there's several mixed problems down here. Some are multiplying, dividing, powers of powers, negative 0. Give these your best shot and enter your answers kind of one by one on the Ed puzzle. Let's see how you do. Okay, I'm going to try my best to use our shortcuts here and kind of talk you through, but if you expanded everything out, that's totally great. Here we have 3 squared times 3 to the 7th, so we're multiplying this. We have 2 3s and 7 3s. That's going to be a total of 3 to the 9th power, 2 plus 7. Next one, we have 7 to the 8th to the 2nd. This is a power of a power, meaning we have 2 groups of 8. 8 times 2 is going to be 16. This is going to be 7 to the 16th power. Next up, looks like we are dividing. 2 to the 10th divided by 2 to the 3rd. We know 3 of the 2's are going to cancel out because the smallest number is 3. That would leave us with 7 remaining in the numerator, so that would be 2 to the 7th. You could have just done 10 minus 3 to get that 7. Here we have 12 to the 0 power. We've learned anything to the 0 power is always 1. Next we have 4 to the negative 15th. That's a negative exponent. We can flip that over and make it 1 over 4 to the positive 15. Next one also has a negative exponent, this time in the denominator, 1 over 9 to the negative 2. We can flip that to the numerator, making that 9 squared. Here we have a division problem, 5 to the 4th over 5 to the 12th. 4 of the 5s are going to cancel out, but this time we have a bigger number in the denominator, so if we cancel out all 4 of the 5s, we're left with nothing but a 1 in the numerator. 4 of the 12 in the bottom canceled out, so that 12 minus 4 is going to give us 5 to the 8th in the denominator. Okay, 1 over 12 to the 0. Well, that 12 to the 0 is going to become a 1, which would give us just a 1 over 1, which we can definitely simplify to 1. Last one, we have 6 to the 3rd to the negative 1. This, I'm going to use our power rule first. We have negative 1 groups of 3. That would be 3 times negative 1, 6 to the negative 3rd. And we've learned with negative exponents, we can flip those over, giving us 1 over 6 to the 3rd. All right, take a few minutes to write your 3 to 5 sentence summary. Make sure you're answering those essential questions at the top. I hope this video was helpful.